For today. Hi everyone. So we'll go into our third day and last day of the Intro to Unix command line workshop. So let's get started. So today, let's summarize. So first day we saw how to navigate through the file system and so on. Yesterday we saw how to do some text processing and visualizing some files, and we also work with regular expression. And today what we're going to do is we're going to learn how to make some scripts. So we're going to learn awk, which is also text processing / scripting tool. We're also going to learn a bit of shell scripting. And lastly, we're going to see a couple of Hoffman-2 specific commands. And then I'll give you a quiz. So if you take one of the class 275 A and B, you have to take the quiz. And for the other, I highly recommend you take the quiz. Just a couple of questions and just to see if you learn something. So highly recommend it just for yourself to kind of see what you learned. Okay, so as a summary of yesterday, what did we see? So we saw a couple of commands to visualize files, like cat and less, and also head and tail that only shows the begin or the end of the file. We learned a couple of commands that can be used to process some text. So like cut, that allows you to extract certain fields in files, certain columns, for example. We also seen paste, which allows you to join multiple files with certain separator, for example, either line by line or file by file. We also saw WC, which is word count, which allow you to count how many lines is in a file or how many words is in the file. We also saw diff, which is a command that allow you to compare two files to see what's the difference between two sets of files, what's been modified, what's been added, what's been deleted. We also saw sort, which is a command that allow you to sort your file by column, for example, either alphabetically or numerically, and so on. We also saw unique, which is a command to extract unique lines, or you can also do the opposite, like only get duplicate lines, but basically to remove duplicates. We also saw how to redirect the output to a file with the greater than symbol or double greater than symbol. So either it's overwriting the file or it would append it to the file. We also saw the pipe command, which allow you to combine multiple commands into only one line. And so basically just redirects the output as input of the next command. We saw grep and regular expression. So grep allow you to search for a specific pattern in a file. And then we saw regular expression, which is how you can form or specify this pattern. We saw sed, which is a stream editor to like find and replace pattern or insert or delete lines, for example. And also very quickly, we saw echo when we were doing the regular expression as an easy way to print something to your standard output to your screen. So that's all we saw yesterday. So on yesterday point, there is a couple of things I didn't necessarily mention yesterday, but you might want to know. For example, on sed, you can use a -e flag, and that allows you to combine multiple sed commands in one line. So if you want, for example, to remove the second and fifth line, so yesterday I simplified by just doing one command at a time, but you can specify multiple commands. So here is the first sed command that say insert kiwi before before the second line, and this is the second set command. That is insert kiwi before the fifth line. And so you can see the output here. We have kiwi here and kiwi here. So basically, we've said you can also add multiple commands directly. So that's something that can be good to know. Another thing, when you sort, so I told you you can sort numerically with the n flag, but there is also another option that you can use to sort numerically, which is the -g. And so that's allow you to handle scientific notation, for example, which won't be handled well by just the -n. So if you have a number in scientific notation or maybe even decimals, you might want to use -g instead of -n. And last thing, kind of a reminder as yesterday. So when you use sed and you want to replace in the same file, you should use the -i option and not redirect to the same file. So that I did tell you yesterday, but it's really important. Okay, another point, if you might want to run this type of command if you have some text to process on your local computer. So on Mac, these commands should exist. However, they tend to be quite old compared to the Linux ones. So not as, you won't have all the same option, and so you might be frustrating because it's not going to work as you want. But you can install the newer version. You just need to install Homebrew, which is a Mac package that allows you to install Linux different package. And then you can, with this Homebrew, you can install more recent version of all those commands. So if you don't want to use Huffman 2, but want to do some text processing on your local computer, you can do that. But if you're on Mac, I would recommend you to install the newer version of this command if you need them. If you're on Windows, you can also use the local terminal from MobileXterm. It has most of the Linux commands, so it should have all of those. Or if you have Windows 10, you can also install Ubuntu, for example, on the Windows subsystem for Linux. So if you just want to do something on your local computer, it's totally feasible to use the same command. Okay, so then I'll go on to the exercise from yesterday's slide. So that was the question from yesterday. So I hope it wasn't too hard and you managed to do most of them, but we'll go through. Okay, I'm actually gonna connect even though I didn't say it for you, but let me just first connect. Oops. You can also connect already to Huffman 2. Okay. And I have my intro to Unix. So you should have tried to do that yesterday, but we're gonna go through it. So what you would have done, first question was create a practice folder under intro to Unix day 2. So then you would just type make dir for make directory practice. And then there was a file that was called practice.txt. So the question was move practice.txt to the practice folder. Then you would have type. So I hope you managed to do all that on your own. You would type move practice, and then you would specify which folder you want to move this file in. Okay. And then, so I'm gonna go into that folder. That wasn't specified, but so the question was, how many lines do we have in practice.txt? So we saw that yesterday we saw the wc command -l that gives a number of lines. So normally you would should have this answer, and I hope you managed to do all that on your own, which give you that this file has 16,602 lines. The next question was, how many different gene biotype do you have? To do that, you need to extract. So let's just first look at how the practice file look. There's always, oops, it's always easier when you know what's in the file. And so I'm actually gonna put it bigger just to see better. So we see we have a first column here, that's the chromosome number. Then we have a second column, that's the start point. Then a third column, that's the end position. We have gene ID, gene name, and then that's the protein biotype. And so that's 3, 4, 5, 6. That's the sixth column. And so based on what we saw yesterday, you can extract this column with cut. So you would extract it first. And this file is separated by single space. So I need to specify my delimiter when I use cut, when it's not a tab by default. And then I need to specify which field I want to extract. And so in that case, it's a sixth column. And then the question was, how many different biotype do we want? So basically, we want to know how many we have. So we saw yesterday that we can sort them. When we want to do some unique, we always sort them because, well, unique or even sort you. So you need to sort them to be able to remove what you need. And then we don't care exactly what biotype there are. I mean, I could do that so that you see. So that would give you all the line with all the biotype that exist. But the question was just how many of them were there. So then you would just use WC to count. WC-L. And that's 18. So I hope you managed to do that on your own. Then the next question was, how many processed transcript gene do we have? So to do that, we need to look for a processed transcript. So to look for a pattern we saw yesterday, we have the grep command. So what you can do is grep for processed transcript. And you need to grep on your file. And then if you want to count, then again, it's WC-L. And that will give you that there is only 3 processed transcripts in that file. The next question was, order gene by highest fold change value and store name in a new text file. So if I put bigger. So then we had this number. So that was like fold change, and that was p-value. So we want to sort by fold change because the question is what's the one with highest fold change. So fold change is the 7th column. So then we would sort by the 7th column. And as I told you yesterday, so it's better to write 7,7. And in that case, we have like decimal numbers. So that's where you will want to use a G option instead of the N to sort numerically. And because we want the highest fold change first, because we want the one with highest, then we'll sort in reverse order so that it's decreasing. So we'll do your 7,7 G to sort numerically in scientific notation, and R to sort in decreasing order. And then we're asking for to store the gene name. So basically, first you sort your whole file, then you can extract only the gene name. So then you would use cut to extract the gene name. And same, our file is delimited with a space, so we need to specify the delimiter. And the gene name is the 5th column, so then you would extract only the 5th column. And then we're gonna store that result into a new file with its stop genes. And we can just check what's in top gene, just to make sure we took the right column, for example, or just to double check. So here we have a bunch of gene name. The second question was, the next one, not second, but the next one was to order gene by highest fold chain value and store the fold chain. So it's like almost the same command. It's just that instead of extracting gene names, you would extract fold chain value, which was the 7th column. Oops, and I overwrited my previous. I'm gonna redo it. I overwrote it. I didn't change my text file. Top values. .txt. Okay. And now the question was to combine these two files. So to combine these two files, we saw the paste command that allow you to combine multiple files line by line. So then you could just paste your top genes and your top values. And then you will store it into a new file that's called combine.txt. And then the next question was print the gene names with the highest top fold chain. So given that we already sorted our files, then I just need to do a head. And if I want the top 20, then I need to specify that I want the head to print 20 and not 10. And I was only asking for the gene name, which is the first column of this combined file. And here it's by default, it should be tab delimited. So I could double check, and so I just extract the first field, and then we get 20 genes that are ordered by fold change. Technically, you wouldn't need necessarily to split these two commands. They're almost the same. So you could extract at the same time column 5 and column 7. That would be faster. If you had to do that in real life, you probably would just write 5, comma 7, and you would extract both columns at the same time. And the last question for the homework was, how would you delete the line from 300 to 500 and sort in a new text file? Then you would do sed, and what we saw yesterday, you can specify lines where it should apply. It would be 300 to 500. And then you would need to say, I want to delete. So that's a D character. And then you want to delete that from the combined text, and you want to put it in a new file, which is called filtered.txt. Yeah, and so that's what, like, the answer to the homework. Do you have any question on G? Okay, so I have one question actually. The G, so I mentioned it at the beginning. So the G is another way to sort numerically, but it's allows to sort. It's allowed to sort scientific notation. So if you had something that was numeric, but e minus 10 for like 10 power minus 10, for example, then that would still work. It will understand that as a number, as a correct number. So it will know how to order scientific notation, which N doesn't. So G is for general numeric. So it handles decimals and scientific notation. Do you have any other question on the homework? Doesn't look like it. Okay, so let's go to today. So again, if you can connect to Huffman 2 if you haven't done so yet today, so either use your terminal or your SSH client. And as yesterday, we're gonna ask for an interactive shell. I mean, it's not gonna be very computer intensive, but at least you'll learn how to ask for an interactive shell. So we did that yesterday, but you can do it again. Ask for a session that's 3 hours long with 2 GB of RAM. So I'm going to do that. And yeah, and and be careful. I often tend to put space after my comma, but if you do that, it's not going to work. So be careful never to put a space after the comma. And then it's going to take a bit of time to give us our interactive session, but it shouldn't take too long. Sort, print to the output if you don't specify a new file. So it's not going to overwrite your text file. It's just going to print to your screen. Most common in general will tend to print to the screen. So if you want to save it, you would need to redirect to a new file. Yeah, I would say most of Unix common by default print to the screen. Okay, so I got my interactive node, so I'll wait a bit longer for you. And as we saw yesterday, you'll see it here. It's start by N. That's a compute node. And if you're on the login node, it starts with login. So let's wait a bit longer for all of you to get a compute node. And if you already have your compute node, we're going to do as yesterday. So I have the material on my GitHub page. So you can either download them and copy them with the SFTP client like FileZilla or CyberDoc or MobExtern, or you can just use the git clone option. And actually, that's a good it's a good place to try this search and try to look for Git. And so that's the one from yesterday. So I'm just gonna press like escape or something. Oops. And then I'm just gonna change the day 2 to 3. So that's where this search Control R to search that I told you the first day can be useful. And then if you don't remember how it works, so when you actually, I'm going to do it again to show you. So you would press Control R. It's going to start. I mean, if you did Git yesterday, of course, it will start the search in your history. And then you would type what you're going to search for. So I'm going to search for a command that had Git in it. So give me my last one that had a Git, which is was a grep. It was for the digit. And then I'll go to the previous one by pressing again Control R. And I'm going to continue a bit longer. And then here I have my command that was my Git clone from yesterday. Then I can either press Escape or any arrows. And I'm just going to modify my command from yesterday to put a free to download the material for today. I'll wait a bit until you have all the materials. Once you have the materials, then you can extract them as we did yesterday. I mean, if you did so if you did git clone, you need to go into the folder that was created. So in my case, Intro to Unix Day 3, and then you'll need to extract the files. If you copied from the SFTP client, then you can create a directory and put the tar file in that directory, and then you would extract that tar file. So I'm going to extract the tar file with the different files for today's. I'll give you a bit of time to do all that. Okay, I'll hope you all have that. Manage to download. Oh, you're still waiting for your interactive node. Okay, well, we'll wait a bit longer then. In the sort, the G option is for general numeric. So it's more powerful than just the N, which is numeric. So the general numeric will be able to sort correctly, even if you have a scientific notation, like 5 E minus 10, for example, versus 2 E minus 3. So it's still going to be able to order correctly, even if you have scientific notation. Otherwise, the numeric will mostly, it's definitely work on like integers. In my work with digits, like decimal number, I would think so. But if you have scientific notation, then it's not necessarily going to work. So if you want, for example, to sort p-values, they will tend to be in scientific notations. So that's where you would want to use the G. So here we're ordering by full change. So it might have worked with N, but if somehow you try N and you have a weird ordering, then that might be because N, you have like scientific notation or things like that, and N can't do that. So that's where you need the G. So G is sort by numeric, but it's more powerful than N. Do you have your interactive node, Marie, or everyone else? I mean, if it's too long, not yet. Well, okay, so yeah, if I try again, or I mean, it's not super computational intensive. So if it just takes too long, you can just do it on the login node. We won't, it's not a big file that we're going to process, so it's not a big deal. But yeah, it's better when you have big files to use an interactive node. But yeah, it's nothing big, so you won't make the logging node crash. So if it takes too long, you can just do it on the login node. Do you want me to go back to reshow the command to get the interactive node? Just in case you have a typo or something like that. And as I said, if you want to abort, like if you're waiting for a node and you want to stop, I did say that on the first day, but first command you need to try when you want to stop something is Control-C. Should kill the process and bring you back to your shell command, and you'll be able to to run any other command. L flag is, I think it means list options. So basically, it's allow you to say, okay, what's coming next is some option, and then you have like some keys like H. I think H is for hard threshold, and RT would mean runtime. So here's the -L mean, okay, what's coming next are a bunch of options. Then the HRT is for hard threshold. So that means they're not going to be, I mean, as soon as 3 hours run out, they're going to stop it. RT means runtime. So it's hard threshold for runtime and hard threshold for data, and data is the RAM. And then you specify the value. yeah, I'm going to show the Git address again. I have it. I'm going to put in the chat so that you can have it made easier. I'll copy it. Okay. And to copy, I mentioned it yesterday. You can copy on your clipboard on your local computers. And then when you're in the terminal, then you would press Control-Shift-V if you're on a Windows, and maybe Command-Shift-V if you're on a Mac. That should paste whatever in your clipboard on the terminal. Are you good? Or not yet? Okay, good. Marie. I'm just gonna continue a bit telling what we're gonna do next. So the couple of things we'll see today is, how to do some scripting, basically. Most programs are basically, most scripts, yeah, so basically scripts are programs that you just interpret at runtime. So you just launch them and it's like interpret what the script is doing and do it at the same time. Most popular tool for Unix scripts, for scripting under Unix, are shell scripting. So we'll see that at the end today. Perl is popular also. Python. If you do NGS, a lot of tools for NGS tend to be written in Python. So it's quite popular under Unix. Awk. So awk, you can also do some scripting. Different type of scripting. It's not necessarily shell scripting, but it's just awk scripting. That's the name of the command. And sed is also considered as a scripting tool because you can make your find, replace, etc. And small comments, sed comments are basically like mini scripts. So we're mostly going to see today shell scripting and awk. So we'll start with awk. So awk is software or command that reads a file line by line and parse. So you can parse the data into field depending on the delimiter. And then you can make a lot of operation on the different fields and so on for all for every line of your data. So it can be very powerful as a text processing. You can do a lot with awk. So for awk, you have some flags. Like one of the flags that is the dash capital F. So the capital F is a delimiter. And by default, it uses something that's white space or blank. So white space or tab should work because tab is also kind of a blank character. So by default, it should take white space, and tab should also be understood. And basically it works. So you have some flag if you need to specify anything. Then you can specify a condition and like an action, and then gonna do this, check this condition and do that action for every line of the file. So conditions can be search pattern we've seen yesterday. So you can search for something. You can also compare stuff. So you can do something if something is bigger than a value, or if two things are equal. And you have special condition, like begin and end. That can sometimes also be very useful. We're mostly going to see end, but sometimes begin is useful too. And the condition begin or end is basically means, so if you're at the beginning of the file, run that. And then it's going to continue for every line to run the next stuff. And the end condition is like, you run whatever you want on all your line. And when you, at the end of the file, you run something else. So if you want to add something at the beginning of your file or to calculate something at the end of the file, then you can do that with the begin or end conditions. Then you have a condition, and then you have actions operation. So operation can be print something, can be calculate me something and print it. So you can do some calculation. You can also have more tests. So you can have if or for loop within your operation. So you can really do some more complicated text processing with awk that you wouldn't be able to do with sed. So awk is quite powerful in terms of text processing. Okay, so for example, what you can do with awk is print specific column. So as we already seen, you can use cut to extract certain column, but you can also do that with awk. And so in awk, a field is coded as this $, and then the number of the field. So that would be field 1, that would be field 2, field 3. So $2, $3, $4, and so on. And if you want to print the full line, then it's $0. So $0 would be the full line. Otherwise, to get a specific field, it would be $ and then the field number. So for example, in our intro to Unix day 3, I'm gonna list what we have. We have a couple of files, including this test.txt. And so we're gonna try on that file now. So as I always, and really I do always look first what's in my text file so that I know and I can write my comment. So I definitely would recommend you to also know what you have in your file whenever you want to process them. That helps a lot. But that's basically that. So yeah, I have all this same thing here. So if I was to want to print the 4th column, which is the gene ID here, what I can do, I could have done the cut as we saw yesterday, but I can also do the exact same thing with awk. So you could do awk, and here I'm not specifying any condition. You don't have to specify a condition. If you don't, that's going to apply on all your line. So here I just want to print the second field for all my lines. So I'm going to say print, and then this $4, which is a 4th field. And then I want to apply that on my test.txt. And so in awk, the quote symbol around the curly brace are really important. So don't forget them. You always need this quote symbol around like the condition and so on. So basically that's a delimiter for your awk script kind of. So whatever is in between those quotes is basically the awk script. Okay, and so basically you see now I extracted my gene ID. I mean, I could totally have done that with cut, but you can do the same thing with awk, and you can do way more with awk than what you would do with cut. So we're gonna see a couple of things. So you can print different columns. So you can print column 4 and column 5. So here's a comma means, can we do print a range in awk? So actually printing a range in awk is not the easiest. You can, but you will need to make a for loop. So if you just want to print a range, I would use cut because it's easier. You can specify a range in cut. It's possible in awk, but you'll need to do a for loop. You can specify different columns. So here, what we do is we say print the fourth column, and comma means as a field, and basically print the next field, which is comma 5. So I'm gonna, just for you to see, if I forget to put the comma, then it's gonna print both, but it's not gonna separate them. So, and if we do put the comma, so you really need the comma because it tells you that's two different fields. And then no, it did add the field separator in my output. So you can print multiple column. You can print something else. So you could say, I want to print Gene as my first, or Gene ID, for example. I wrote Gene, but I could, it's like Gene ID. You can say, I want to print Gene ID as my first column, and then I want to print the Gene ID, which is the fourth column. So you can do that. And same, be careful here, you need the quote. And given that the outer quote here are single quotes, you need the double quote here. So yeah, you need to be slightly careful with quotes in awk to have to put the correct one at the right place. But here we see we added a column that has Gene ID, and then we just printed whatever was in every line. And so sometimes cut can be easier for range, but awk is way more powerful. It would be harder to do that in awk. I mean, you can't really awk just extracts. You can't add anything to your line. So cut. So cut only extract, and then you can't add anything to your line. With awk, you can do a lot. So here you see you can add something before, you could add something after. So if you want to, if you run some program, you process, and you just want to reorganize to have something nicer, then awk is great for that. Or just to extract a bunch of gene, or add what the header are, or you can do all that relatively easily with awk. And you can also do calculation with awk, which can be really, really convenient. So for example, if I go back to this here, and I add a new field as my output, which is, for example, I'm going to multiply the first column. I mean, honestly, it doesn't mean much. The first column is the chromosome number, and the seventh column is fold change. So, I mean, you wouldn't do that in real life, but just as an example. So you can do a calculation with awk. So you could do that, and then you've calculated a combination of two fields. So here we multiply the first field with the seventh field. So you can do calculation with awk. You can add stuff, you can print. So that's very, very convenient. You can also have condition in awk. And yeah, please try to make it at the same time as me, because it's how you'll learn how it works. So as I told you, actually, I'm gonna just rewrite it. As I told you at the beginning, you can have a condition before your action. So you can have a condition that's a pattern, as we saw in sed. You can, it's basically almost like, it's written the same way as sed. So you have like slash, then your pattern, and then process transcript, for example, and then print line. So $0 means print the full line. And so what it does here is going to only print the line where it finds process transcript in the line. So that single comment by itself would be relatively similar to what you could do with grep, but you can also do that with awk. And so here we only have 3 lines, and so we can see here the biotype is process transcript. So you can easily filter gene if you wanted only protein coding gene. You can very easily filter them and do more calculation of different fields at the same time. And you can also make comparisons. So like in this file, we have p-value. The last column, the 8th column, is p-value. So we could totally only select and print the gene for which we have a significant p-value. So, and for that, we would say we want to compare as our condition. We want to compare the last column, which is the number 8, to a significant p-value. So we would say we want a p-value that's below or equal to 0.5. And then we want, I mean, if that condition is true, then I want to print the full line. So here, basically, we're filtering to only keep gene for which a p-value is significant. So you can very easily filter based on p-value or full change. You could do both at the same time. So here we see we only have 2 protein coding genes for which we have a p-value that's below 0.05. So that these two. So you can filter relatively easily with awk. And so in terms of comparison, so if you want to check if something is equal, if you want to check if something is equal, it would be double equal sign. Then, I mean, it's quite obvious, but more is greater than sign, less is less. So that's all the comparison symbol that you can use in there. It's very often those, so nothing special. How do you distinguish printing the line versus a column? So as I said, so if you want to print the full line is a $0, that's a full line. Otherwise, if you want to print a specific field, then it's $, the field number. So if you want to print a second field, then you would write $2. So the $sign is, yeah, so any number from 1 to whatever number of column you have will print a specific column. And if you want to print the full line, it's $0. That means full line. So that's why here I have $0 and before here, for example, I had $4. And you can also combine condition. So you don't need, you can have multiple conditions. So you could, for example, try to filter only protein coding genes. So biotype, again, is the 6th column. And then you can say, I want my biotype to be equal. And again, be careful with the quote. It has to be double quote within the single quote. So here you would write protein coding. So you're specifying that the biotype must match exactly protein coding. And then if you want to end, if you want to combine in an AND way to condition, then you would write this AND twice. So that means I want the biotype to be protein coding, and I want, here it's a full change. Column 7 is a full change, and I want the full change to be less than -1. So I want downregulated protein coding genes. And then I'm just printing the full line. And here I have my protein coding. So I should put that bigger. So here you can see they're all protein coding genes. And if you look at the full chain, they're all below -1. So you can filter, you can combine condition to do your filtering using awk. There is a question about, can we switch double quote and single quote? I wouldn't recommend that. I'm not sure if it would work. It might, but usually people put the single quote outside. Yeah, the single quote outside and the double quote inside. The quoting do have sometimes a meaning. So I'm not sure it's going to work if you do the opposite like that. It might, yeah. So it doesn't on the, yeah, because, okay, so that's a bit complicated, but when you have something in single quote, bash is not going to try to expand. So I'll go a bit, I think I'm going to explain that a bit later. So the single and double quote don't have the same meaning. So that would be understood by bash as a variable. And when you have double quote, if it sees something like bash like that, bash is going to try to replace with the value. And when something is in double quote, bash doesn't try to evaluate it. And so that's why for awk, you need to put the single quote outside, because this way bash is not going to try to evaluate anything, but awk will understand it. So it doesn't work the other way around from what we just tested. And that's because otherwise bash is going to try to understand stuff in your command. And you don't want that. You just want awk to understand it. So yeah, always single quote outside for awk command and then double quote inside. Okay. If you were, okay, so I guess the reason that why you might want to do that, if you were to want to match a quote within a symbol, you would need to like escape it. I mean, here it's within a double quote, so it would work. But if ever you have issue in text that you have like single quote and you want to put some single quote that can mess this up, that's the escape character. That's the same as in grep. So if you have something that doesn't work, try to put a backslash before it so that it understands correctly if you ever need. But yeah, for awk, single quote outside, double quote inside. Okay, and so if you were to want an or, so if you were to say, I want either Magin to be a protein coding or I want them to be done regulating more than twofold, then you would put double pipe symbol instead of the double N symbol, and that would make that would combine your two conditions in an or fashion, in like either one of them is true. Yeah, so let's couple of examples. Let's try that. Let's try to understand what it means, and yeah, really try. Oh, I'm gonna just shorten that again. So let's go on that one. So what would that command means? So here, the first thing you have a condition that the 8th column needs to be below 0.05. So that's your p-value. So 8th column is p-value. So we want a significant p-value. And if the p-value is significant, what you want to do is you're going to print CHR. So that's because here the chromosome number, it's just a number. So if you want to write CHR like a GTF, or usually it has CHR chromosome number. So you could add CHR to the first field. And given that we didn't put a comma here, that means it's going to just concatenate these two strings without anything in between. So we'll have CHR, whatever is here. And then we're going to print the second field. And oops, my curly brace is a bit shifted to the left, but here we're going to print the second field, so the start, the end. And here we're going to print the real fold change, because here our fold change are log2 fold change. So here we're going to just convert it back to a normal fold change. And then we're just going to print the p-value. So basically, we're removing anything, gene ID, and so on with that command. So we can try it. So first, we want the p-value, so the 8th column to be below 0.05. And then we're going to print CHR before our chromosome number. Then we're going to print as is the second field, then as is the first field. And then we're going to convert our float change back to real float change and not log2. So you can do power with awk. And then we're going to just keep the p-value as is. And then you close your single quote, and then you do test.txt. And I forgot to close my double quotes. So yeah, if you have an error, it's going to tell you what you missed. And you say that's not terminated. And so that's because I forgot to put it at the end of CHR. So now that I fixed that, then I can rerun it. And so you see, I just added a CHR before my first column, and then I just grab and converted this one into real full change. We can actually, I'm going to just add the column 7 before, just to see that the operation is well done. So the log2 full change was -1 something, and if I convert back to a normal full change, then have 0.34, so which makes sense, a bit less than 0.5. So you can see that was our previous column 7 number, and that's our new converted in full change and not log2 full change. Okay, so it's 10, so let's do a quick break and start back at 5 past 10. I'm gonna post the recording. Okay, I hope you're all back. Let's continue. So awk has a couple of built-in variables which can be convenient sometimes. So these variable are, probably the most useful one, are an R and an F. An R means number of records seen so far. So if you process only a single file, then it will be the line number, basically. And it also have another variable, which is an F, which is number of fields of the current record, so of the current line. And so that can be convenient sometimes because you can do operation based on the line number. You could do operation based on how many outputs you have. So like from the question before, can you print a range in awk? Even though it's not easy, but if you were to want to print from field 3 to the end of the line, then you could base that on the field number. So you could have a for loop, and then that's do something from the number 3 for the field to the last column that you have based on the field number. So that's why they can be useful. And so let's look at this. So basically, you just need to write this variable in awk, and it's going to be understood as either number of line or a number of fields in the current line. So for example, let me write everything again. If you do awk, and then for the genes that had a significant p-value, and you would still have your condition, but now our operation or action is going to be to print. So we're going to print the line number, basically, as the first field, and then I'm going to print the rest of the line. That's on our test.txt. And so if I do that, you can see that, actually, I'm going to if I do that, you can see that was my chromosome number. And here I added which lines. I added the line number. So the 2 genes that were significant were on line 5 and line 9. So number of line can be convenient. And we'll also see later why it can be very convenient. You can also use this based on the, you can also use this built-in variable in your conditions. So you could easily say only print lines 6 from, yeah, line, basically remove the first 5 lines. So if you do, I want to print only when my line number is greater or equal than 6. What does mean that for the first 5 lines, you're not going to do anything. And then here I'm going to print again the line number and the full line. And I'm going to just stretch it so that you see better. And so here you can see we have 6, 7, 8, 9, 10. So if, for example, your file has a header that has 10 lines, then it's also very easy to remove them if you want to process whatever is after. So you can definitely use the number of record in your condition to like remove a certain number of lines or certain lines. Okay, let's try a couple of things. I'm gonna also do it, but I'll leave you a bit of time to do that. So try to print line for genes on chromosome 3 in our test.txt file. Try to print line for genes that are more than 100 kb. Try to print line for gene on chromosome 1 that are more than 10 kb. And try to print line for gene with an absolute fold change of 2. So I'll just give you a bit of time to try that, and then I'll do it with you. Yeah, because we still have some stuff to go through, so I don't want to lose too much time. So okay. At least try to see how you would do it, even if you don't write it. And this way I'll do it, and you can at least make sure you have the understanding on what needs to be done. So for the first one, we want gene on chromosome 3. So basically what we want is the chromosome is the first field, right? So what we want is to make a condition based on the first field. So the first field is 1, is $1. And our condition is, I want this to be equal to 3. And then you just want to print the full line. So then you want to, and I forgot the, and you want to print the full line, which is $0 on our test.txt. And yeah, I put a single quote here that I shouldn't have. Okay, and so now we can see that it printed 2 lines, and we can see that the first field of these 2 is 3. Okay, so next one. How would you print lines for genes that are more than 100 kb? It's very similar, basically. It's just our condition that's different. So here we have the start and the end. So what we want to do is to look at the length, which basically is the end minus the start. So the end is the third, then we want to remove the start. So we want to know the length, and actually we should have a +1 technically for the length. And then we want to compare that to 100 kb. So if we want things that are more than 100 kb, it can be either equal or not, then you'll have 100,000. So that would be our condition. So you would just subtract the end, the start to the end, such that you have the length. And then you would compare to here 100 kbs. And then you would print, and same, you would print the full line. And then you'll have these 2 genes that are more than 100 kb. Then you can, the next question was gene on chromosome 1, and that also more than 10 kb. So basically, we kind of want to combine the two things we did previously. So the first thing is check on which chromosome it is. So here we want it to be on chromosome 1. So we wanted that the first field is equal to 1. And we also want, so we need to combine this condition with the double n sign. And then our second condition is also length. So length, as we just saw, we need to subtract the start from the end at +1. And we want to compare that, this case, to 10 kb, because otherwise you don't have any output. And then we want to print. A full line. And so here we can see chromosome is indeed 1. And then if you were to check the difference, you'll have a length, and that's more than 10 kb. And the last one is print gene with an absolute fold change of 2. So sadly, the absolute doesn't exist in awk, so you can't do that. However, absolute value is just 2 conditions. So what you can do is check our fold change. That was our 7th column. 7. So you can check the fold change. And so our fold change is in log 2. So I'm going to do, I want my fold change to be either less than -1. In this case, I want either that or to have a fold change that's greater than. So this case, that's why I'm putting the double pipe symbol, just because I want an or. So I want either a fold change that's less than -1 because we're in log 2, or I want a fold change that's bigger than 1. And so, yeah, that's basically our absolute fold change. But the absolute comment doesn't exist in awk, so you can do it this way. And then you can print $0, just close the awk command, and then do that on your test.txt. And then here we have -1 something was our gene, 1.4, -1.3. So you see that did work, -2, -1.1, and so on. Okay, so you can see that it's quite powerful to filter if you want to filter. Did we? Maybe I forgot the +1. The +1 is when you have length, like if you want the length from 1 to 2, it's like 2. But if you just do n minus start, then it's only 1. So that's why we did the +1. It's like, okay, how do we say in English? It's like when you have when you have a field and you have these fences, like you have the wooden things and the in between. So it's like border and interval difference. So if you're counting how many posts you have, then you need to do +1 compared to just the difference. So yeah, that's the only reason we did +1. Yeah, so that's exactly what I just did. I showed you and how to do that. This couple of questions. I need to do that. Okay, so another built-in variable in awk that can be useful sometimes are fs and ofs. So fs means field separator, and OFS means output field separator. So FS is the input one, so that's the text you want to process with awk, and OFS is what you want to output. So I did mention before that you can use the flag -f to specify the field separator. So if we look at the ag19.gtf file, so I'm just gonna, well, I'm not gonna do it, but if you do ahead here, you can see that it's not space separated, it's tab because it's a line. So if you just print a couple of lines, you can easily see if it's, most of the time you can easily see if it's tab or space, just because space won't align. It would just be a single space, and you can see here that it's bigger. So that tells you it's tab separated. And this 9th column has space in it. So if we don't put the output separator, then we're gonna basically split also the 9th column. So if we don't put the field separator, we're gonna also split the 9th column because it has space in it. And we can try that. So if we were just to do awk and not specify the field separator, then let's, for example, print the 1st column and then the 9th column. And I'm also just going to print the number of fields for every line so that we can see. And I'm just going to print the first couple of lines. We don't need to print everything. And I'm going to stretch it, otherwise we won't see too much. Okay, so if you check here, so that worked. Then here we only have the first part of our 9th column, and it's telling you we actually have 12 fields. So that's because by default the field separator is a space, and here we have tab. So we can specify what field separator it should use. And so we can do that with the -F. And to specify a tab as field separator, then you would put a \T. So that's how you specify a tab. And so if we do that, then we can see if I run the same command except for this field separator, we can see that now it printed the full 9 column, and the number of field is indeed 9. So you might, be careful what's the separator in your file. Make sure you specify it if it's not space. The only issue here is you see it did print with a space here, and then we still have space in our 9 column. So if you were to want to process further, that's going to be annoying for you because you're not going to be able to differentiate this space and this space. So you might also want to specify the output separator. And to do that, there is not like simplified flag to do that, but you can still do that. So basically fs and ofs are awk variable, and you can specify any awk variable with the -v, and then you'll write your awk variable name and you'll say whatever its value is. So instead of the -f, we can also say that's an awk variable here. I'm specifying what's coming next is awk variable. And then the awk variable name is fs. So basically the -f is a shortcut for that. And then you could also specify the input file separator here, but you can do the same for the output file separator, which doesn't have a shortcut. So you would need to do that for the output. So if you were to, because we have space in the 9th column, if you were to want to keep a different separator, you could either rewrite a tab. So you can also want to separate your output in tab. You could, if you want to make clearer, you could also change and say, oh, I want to change from a tab separated to a comma separated file, and you could definitely specify it here. And so if I do that, you see now that it added a comma here instead of a space and a comma here. So if you want to change the field separator, you can relatively easily do it with awk too. And so if you want to put the tab, then you would also put \T. And now here you can see we have more than one space. So we have a tab here, and also here, but we didn't have. So yeah, so when you work with awk, it might be useful to check what's your field separator, input field separator is, and make sure that you're okay with a space. I mean, if we don't want to keep the 9 column, then space would totally work because we wouldn't have any issue with the other column. The v flag is to specify that's coming next is an awk variable. So fs, OFS are awk variables. So you can modify their values by putting the -v before and then writing what value you want them to take. So here we said what's coming next is a variable. That variable is fs, and I want fs to take the tab value instead of the white space value. And same for the output field separator. And this one, if you just want to change the input field separator, there is a shortcut -F, but there is no shortcut for the output field separator. Yeah, so with awk, you can also have some more operation. You can have if-else condition. You can also have for loop. What we've seen so far with awk, you had a condition and an action, but basically just an if. So if you want to do something differently, if it's not true, then you can also use if-else. You're just going to write that into the kind of action or between the brace, the curly brace. You can have if your action, then you will need a semicolon to separate the action from the else conditions. So you would have if a certain condition, then do something, and otherwise, actually it's else if. Otherwise, do something. I'll correct that. Otherwise, do something. And you can also have else if. So you could have else if condition action. So you could have if, else if, else, and so on. So yeah, you have that's what we were using before, awk condition action. You can do the exact same thing with just a if statement. So if condition action, that also do the exact same thing. But the advantages of putting if within the curly brace is that you can have else or over or else if. So for example, let's say if we're on chromosome 18, that's our first condition. Then I want to print the number of records, so the line number, and then I want to say it's a chromosome 18 gene. And then that's on our test.txt file. And then if we run that, we can see that for the line 5, it did tell us, oh, that's a chromosome 18 gene, and for the line 9, it's a chromosome 18 gene. We could totally have done the same thing with like the previous syntax, which was this one. So that would have done the exact same thing. You can see. But the difference that if you write the if in your curly brace, then you can have an else or else if. So now with this syntax, with the if inside the curly brace, what we can do is put a semicolon to separate the if condition to the else condition. And then you could have else. And then else, if it's not a chromosome 18 gene, then you can do something. So if it's not, in that case, I'm going to print, same, I'm going to print the line number. And then comma to separate fields. And then I'm going to print it's not a chromosome 18 gene. And so if you do that, you can see the first one, you get not a chromosome 18 gene and so on, then it's a chromosome 18 gene, etc. And that you wouldn't be able to do with the previous syntax. So if you only have an if condition, then you can use both syntax. If you want to have an else, then you need to put the if within the curly brace. And then you can also do else and else if. Okay. Another very useful thing with awk, and that is variable. So we saw awk already have a couple of built-in variable. Can you have it do multiple action in the if else? Yeah, you can have multiple actions. You would put braces, if I am correct. So I don't know what. So if you put comma in print, that's gonna put a separator, but you could also put multiple print. So basically to separate multiple action, you will put, I hope I'm not, we'll check if it works. I think it's how you should need to write it. So you put a semicolon to separate the actions. So you need to put braces and semicolon between your action. So here I would have action 1, which is print the number of record, and action 2 in my if, which is print chromosome 18 gene, and that should do the same. And I made a mistake. Where did I make a mistake? I have a syntax. Did I forgot to? Maybe you don't need the curly brace actually. Let me think. Do I need the curly brace? I totally know it's possible. I just sometimes I lose part of the syntax. If print, else print. I'll see if I have that later. Another question is, if you want a new line, can you use a \n? Yes, totally. If you want to put a new line in your output, you can totally have a \n. That works totally fine. Okay, I'll think about how to put multiple comment. I know it's possible. I just kind of forgot the syntax. And that's why you have manual page, and that's why you have Google. When you don't use it every day, sometimes you forget part of the syntax. So that's totally fine. I also do that all the time, Googling when I forgot. Yeah, so what I wanted to say is you can create your own variable with awk, which can be very handy. So how you do that? I'm gonna take a new line. Okay, so what you can do with awk is have your own variable. So if you have in your actions here, I'm gonna create a variable. So you just give a name without quote because you want it to be a variable. So here you say sum, and you don't put quote around sum because you want it to be a variable. And so here you can say plus equal. So plus equal is basically it adds a certain thing to the sum variable for every line. So what you can do here, we're going to add the 7th column, which is a full change. So basically every line, it's going to put the full, it's going to add the full change to our sum variable. And then that's where the begin and end, in that case, end condition can be very useful. So you do that for every line. So basically for every line you're storing, so it's like a box. For every line you're putting the value of the full change in the sum variable, and you're storing that. And when you finish reading all your file, then what you can do is print the result of whatever is in your box. So open your box and check what's in your sum variable. So you can do print. And here we're going to print sum. Did I put a space? Print sum. So yeah, so you can put you can save thing in your own name and have your own awk variable. And here, so basically we took all the line and we added the log full change. So that's like the sum of all our log full chain. I mean, it doesn't mean much so far, but what you can do, I mean, you could do it similarly with overfilled. So let's try our example on AG19. So what we can do is awk. Then we can save, if we want to print the sum of the column 4, which is the start position. So you could first the curly brace. Then start position is actually 4th column. Then you do that for every line. So you add to your variable. Every time you have a new line, you add the new value to the current value. And then you can print that at the end. So when you reach the end, so this means when you reach the end, print, do that action, which is print sum. And we do that on our AG19 GTF. And so that's summed all our starting position. I mean, you probably wouldn't do that in real life, but you can do it. We're going to do something else, and you're going to see why it's useful to have variables. Next thing we're going to do is you can also print, for example, you don't have to do anything on the line. So you could just say, when you reach the end, I just want to tell me what's the line number. So the number of record. So what is our last line number? So you can do that. And here we see at the end of the file, we've seen 3,000 lines. And so we can check because we know how to count line in a file. So we can see if that's match what WC tells us, for example. So if we did WC on AG, WC-L on AG19, then we'll see it also say that we have 3,009. So that does match. And so why is that useful? That can be useful because that allows you to make average, for example. So if you wanted to know what's the average start position or Eugene, or what's the average full change, etc., then you can do that with awk. So here we did the sum. So how do you make an average? Basically, you take the sum and you divide by the number of value you have. So that means you just sum everything over all your line. And when you reach the end, instead of printing just the sum, you would print the sum divided by the number of record, because we know that when we reach the end, the number of record is going to be the number of line. And so this way, we can do an average. So here we're going to do the average of the start position. And so that's the average or start position. And so you can do that for specific conditions. So if you were to, if you want to know what's the average start position for all the gene on chromosome 2, then you can totally do that. And I have your example that you were asking, and I don't know why it did work before. I probably had another typo somewhere, or it's my else, it wasn't right. Oh yeah, I think it's because if you put the curly brace around the action here, when you have the else, you don't need the semicolon. So that's probably what my issue was before. But yeah, you can have multiple action. So that's an example. So I was almost right before. So let's look at that example. So here we want to have to print the average of the start position only for gene on chromosome 2. So we could put our condition here. That's one option before the curly brace, but we can also put it in the curly brace. And so if we do that, so basically this file has a char. Actually, I'm going to show it first. Add of AG19. It's like a slightly different syntax. So here you see the chromosome is not just a number, it has CHR. So in my hook command, then I need to say if the first column is equal to chr2, then, so here you would put curly brace, then you would do the sum. So we would do as before, the sum, do a sum, and we can't use the number of lines this time because we're only counting on chromosome 2, right? So we also need to keep track of how many genes are on chromosome 2. So that's what the second action is to sort the number of genes that are on chromosome 2. And so you just add one for every line that you process that's on chromosome 2. And then so that's my first. Then when you reach the end of the file, then, well, just for us, we're going to print how many genes there were on chromosome 2. And then we're going to print the average. So the sum over the number of genes that are on chromosome 2. Okay. And so that should work if I didn't make any typo anywhere. So let's see. And that did work. So we have 1,000 genes that are on chromosome 2, and the average start position from chromosome 2 is that value. And so that also did answer your question about multiple action. So you can have multiple action this way. And if you have else, given that what I tried before didn't work, it's probably because I put a semicolon after this red curly brace, and you don't need to. But you can have multiple actions. So that can be convenient, like what we just did here. So you can average on all the file, on specific lines of the file by storing stuff in variable. And also, awks totally work. You can pipe thing in awks. So you can do some easier processing. So like if you wanted to extract a range, which is not the easiest to do with awk, you could do it first with cut and then just put what you want in awk and do the rest of the processing. And yeah, so if you were to want to print the name of the 20 gene with IS4 change, we saw we could have did some sort or some with cut, etc. But you can also pipe that in awk. So you don't necessarily need a file. You can also pipe some other result. Okay, so that's how you can do script with awk. And another nice thing that we don't see, but you can see that when you do some condition, then it can start to be quite long in terms of like this awk script. That's whatever is in the single quotes, it's called the awk script. You can also save that in a file and have awk use a file as its script. So if you want to process the text file and it starts to be long for just a one line, then you can totally save whatever command, without a single quote. So whatever it would be in the single quote, you can save it in an external file and tell awk that the script is in a specific file instead of having to write it in one command. So depending on if you like awk and you start to use processing it, it can be sometimes useful to store all your command in an external file and use that. Okay, so now we're going to see quickly how to do shell scripting. That's very, very convenient to do shell scripting. That mostly, sometimes when you process things, you need to process on different samples. And so you want to make sure you do always the same thing. And so that's where writing a small shell script can be very convenient because you can run it easily on multiple samples and you're certain that you're going to run the same thing. So basically what the shell script is, it's a text file. Well, yeah, a text file where you say what command you want to run. So you can basically run any awk command, any bash command. You could have it's basically a list of commands that bash needs to execute. So it's a text file with a list of bash commands that needs to execute. And then you just save it. And this way you can have very reproducible pipeline and so on. So to create this file, you need to use you can use a text editor like VI or Nano that we already seen. And then you would write all your bash command inside, or all your command inside this file and save it. And then to be able to run this file, then you'll add execution permission to that file that we've already seen how to do that. So, to be a bit faster, I already, did I send this one? I think this one you'll need to write it, but the other one we're gonna see are already put in the list of the file. So just as an example, here we're gonna make a very small script. So for example, you use VI, then we're gonna save that in script. And usually people will put .sh as the extension of a shell script. I mean, technically it could be a text file, but it's just easier. If you have a .sh, you know it's a shell script. So that's usually what people do with put .sh, and I would also recommend to, because you know that it's a script if it's end by .sh. So let's create our first shell script. So use VI, you can say in which file you want to save. And then in VI, if you remember, first thing you do is press I, and then you enter the insert mode, and then you can write your shell script. So how is shell script? What you need to put in a shell script. So the first line is very important, and you need to put the hashtag !bin bash /bin/bash. And so what this line is, so this hashtag ! is called a shebang. And basically that's a way bash recognize this specific line, and this specific line tells the terminal how it needs to interpret the script. So here it say, oh, that's a bash script. So when you execute it, you need to run the bin bash command, because the bash command is always stored here. So basically it tells it that it's a bash script and you need to run it with bash. So for example, if you download online some Python script, then Python script would have the same shebang that tells, oh, that's where I'm going to tell you which type of script it is and what you need to run it. So if it's a Python script, then you would have bin Python. So here it's a bash script, so you have /bin/bash. It's just to tell the terminal that that's a bash script and it needs to run it with bash. So that's our first line. Then we can put a space or not. Then we can use our echo. So basically this script is just gonna, when we run it, it's just gonna print to the screen, hello world. So that's like the typical example. And when you're done with VI, you press escape, that disappeared. And then you press colon, so shift to be able to press the column and not the semicolon, and then right quit. Okay. And so now if I list my file, you see I have this script.sh. However, so far it's not executable. So we're gonna do that right now. So I'm gonna change it and add, as we've seen, the execution permission. So I'm gonna just add it to my user. So I do u plus x, and then this script.sh. And now if I just list all my file, we can see that I have execution permission here and it's turned green. And so now, last thing you need to do is run. You need to execute this script, which is your first script. And so to run a bash script, you need to put the you always need to start with the ./script. This way it knows that it needs to execute it. And so if you type that and press enter, it's gonna do whatever you told in the script. And here we just told the script that it should print to the screen hello world. So when I run it, it just prints to the screen hello world. So that's our first shell script. And then I put a couple more examples. I'm not going to make you write it, but we can look at it, at these examples so that you understand and you have them. So you can definitely try them. So first example is the gtf.sh file. And what this script does, it's going to create a new GTF file for every chromosome in this AG19 GTF and save them into a specific column. So what we can see, I can do, no, I won't have the coloring if I do the cat, but I can just show you that same thing. So you can see I have the shebang. And then what it does, it's create this directory. And what it does, it use awk, specified the input field separator, the output field separator, and it's gonna extract the chromosome 2 and then print. So if you want just to print the full line, you don't have to specify the $0. If you just write print, by default, it's gonna print the full line. So if you don't specify anything. So it's gonna, if it's on chromosome 2, it's gonna print the full line and it's gonna take input from this file, and then it's gonna save it into our newly created chromosome 2 directory, and then in that file. So normally if I run it, if I run it like that, then it should work. It doesn't print anything to the screen, but if we just list, now we have our different newly created folder, and then I can list what's in the folder. And in my folder here, I have this newly created GTF that only includes whatever was on chromosome 2. So that's nice. So you can do things. You can basically put a bunch of bash command into a bash script and just run that, and it's just going to execute all your bash commands. Another thing in bash, so bash script can take input arguments. So you can specify, when you run the bash script, you can add arguments to it. And then when you want to use your arguments, then in your bash script, you need to specify a $1. And so that means it's the first argument that was given after the bash script. So if you want to run this one, so it's basically the same as before, it's just I replace ag19.gtf, I replace that by the first input argument. So now if I want to run that on the ag19.gtf, you need to specify which file this script needs to run on. So you would say, I want to run gtf2.sh, but I want to run it on this file. And so when bash executes that, that's basically the first input argument. So wherever it sees a $sign in the script, it's going to replace it by what you give him here. And you can have more than one if you need more arguments. So you could have ag19.gtf and something else. Then there's whatever you put after, then if you want to refer to it in your bash script, it would be $2. So you can give him as many arguments, but basically it's positional. So whenever you want to use them, you need to say which argument should be. So if it's the first argument, then you have $1. If it's the second argument that you want to use, then it should be $2 when you write your script. But here, so it's exactly the same, but I now can easily change and apply this script to different GTF, for example, because I'm going to give him, at the same time as I tell him to run, I'm going to tell him on what file he needs to run it. So I'm going to remove all folders that we just created. And so if I was to run 2, and then no, I need to specify on which file it needs to run. So here I'm giving it the file here, and I can run that. And now if I relist all my folder, again, I have this chromosome 2, chromosome 21, and chromosome 3 folders, and I can list what's in it. And then I have one file for each chromosome. So I split my AG19 GTF into different files for each chromosome. Couple of tips when you write your bash script. If you want to comment, which you should do, it's always good to put comments. If you want to just for you remember what the next line means or whatever, you can put the hashtag, and whatever comes after the hashtag is gonna, or pound sign, is gonna not run. So you can write some comment saying, oh, I'm gonna print hello next line, or so you can print stuff to remember. So comments, you can add comments. You need to put at the beginning of the line the hashtag. And also what's useful sometimes is that you write your script, and then if it has multiple steps, and then you realize that something went wrong in the second step, you just want to rerun your script, but you don't want to rerun the first step. Like if you, let's say you have a script, you have like 2 steps. So you run it, step 1 worked, step 2 didn't work because you had made a typo or whatever. Then you go, you correct your script. But given that first step ran correctly, you don't necessarily want to redo it. So you could also comment whatever lines are for your step 1 and just rerun your script starting at step 2. So that's 2 ways you can use a comment. And so shell scripts also have for loops, if condition, and so on. So you can definitely automate things further. And so I have a question. Is it okay to write a comment in the same line as a shebang? I wouldn't do that. I think you can write comment before the shebang and after. So I would rather do that and not put it on the shebang line. I would just make sure it might work, but I'm not sure. And I would, just to be safe, tend not to put anything else on the shebang line. Okay, so I'll try to make another break, but I'll try to finish the self-scripting first, and then the last thing we'll have will be a couple of Huffman 2 commands. So I'll try to make a break after finishing all on the self-scripting. It shouldn't take too long. We've seen most of it. So I'm just going to explain loops. So you can have loops. So a loops, how it works, loop in self-scripting, then you have for, then you will write a variable name, and then you can do for this variable name in a specific list. And then you'll have do, and then you do some comments, so you can have multiple comments. And when you want to exit your for loop, then it's done. So for loop is for variable in something, do stuff, and then I'm done. So done. So for example, here have, and take a look at the different script I made as an example. If you have loot.sh, same first line is a shebang line. And then you say for I in 1 to 10. So this means 1 to 10. So that's going to print all number from 1 to 10. If you wanted specific number, if you wanted number 1 and 5, you can write just 1 space 5. That's just going to take number 1 and number 5. So you can write stuff like, for example, in our previous example, we could have write for our variable, we could have called it CHR in CHR2 space CHR21 and so on. Is the indentation sensitive? I don't think so. It's indentation sensitive, but I always recommend to try to indent it correctly. It's always nicer to read, but I don't think it's indentation sensitive like Python. Yeah, so I put this loop example. So here what I do is for the number 1 to 10, I'm going to print step I. And so bash, when you want to refer to a bash variable, basically you need to put the $sign before. So here you put $I. That means, oh, you need to look what's in my bash variable that's called I. And so that's also go back to the previous question on awk about single quote and double quote. And that's what I was referring to. So bash, single quote and double quote don't have the same meaning for bash. And we can see it here. So here I put it in single quote. And so you can see that it doesn't put in like in VI. So I took that from VI. So if I open in VI, here it's red and here it's purple. So this one is not, because it's single quote, bash is not going to try to evaluate anything from it. So it's going to print exactly what's inside single quotes. And so it's going to print $I. It's not going to try to figure out what's in my I variable. And that's a difference with the double quote here. If I put double quote, you can see that the $sign I is now purple. And so when bash sees double quote, if it sees a $sign something, it'll try to evaluate it as a variable. So that's why you need to be careful between double quote and single quote. And that's why also it didn't work. We can't change it in awk before. And so we're going to run that so that you can see if we run this script. So slash, and then our script is loop.sh. And so you can see the first one print $sign I because I put it in single quote. And then the second line does print the value that's in the variable I because I put double quote. So be careful about the difference between single quote and double quote. It doesn't mean the same thing in bash. Okay, so there is a question on awk, so I guess I'll answer later on that one. We'll finish the shell scripting first. And so what's nice is you can also do that on list of files. So for example, you could say for a variable file that are ending with a txt, so you could put the star, which gonna find everything that's finishing, anything that's finishing .txt, and then you would have here I'm printing, oh, I found this text file that has this name file. And so that's nice because you can do that on list of files. So you can just put a script that processes all your file text at the same time. So if I run this script, and so here in my folder, it only found practice.txt and test.txt, but you can do for loops on files. You can also do for loops on comments. So that also can be very convenient. And so here, for example, I can do that on any chromosome that's found in my file. So I can run a for loop, but I can first calculate or get all the chromosomes that exist in my file. So I don't need to know them beforehand. And so that's what the $sign parentheses means. So when you put a $sign parentheses, it's going to tell bash that's a command you need to run and get the output and use it here as a variable. And so you can also specify bash variable. And if you want to add a bash variable, you can write the variable name and whatever the value needs to be. And then you can refer that as any bash variable with the $sign and then its name. So you can create your own variables. For example, if you mapping to reference genome and your reference genome is at a specific location and you don't want to have to write every time the exact location of your reference genome, then you could save it in a bash variable at the beginning of the script and call it like ref. And this way, whenever you need to refer to your reference genome, you don't have to write the full path. You would just say, whatever is in my ref variable for bash, and bash will just get it and use the right path that you only set once at the beginning, for example. And so you see with that, we could do what we did with the GTF .sh relatively easily. So we can check for what chromosome are in whatever file, and we don't need to specify the file here. We could put it as a first input argument. So you can definitely make things way more automated, basically. And so if I just run that loop3.sh, and then it told me it found chromosome 2 in this file, and it found chromosome 21 and chromosome 3. So here I basically just, as an example, how you could write in a more automated way what we did before. So you could do a for loop that look what chromosome are in your input file here in your argument, and then it would automatically create a directory for a new chromosome and automatically do the awk command and save that. And so that would be independent on the number of chromosome, on the name of the chromosome, etc. So you can definitely automate a lot of things with shell scripts. Okay, so I'm going to make a small break. So let's start at 10 past 11. I'm going to answer your question, and then we're going to just see a couple of comments that are implement specific after. And so let's take a small break. Okay, so no, I mean, you know how to do some awk scripting, some very simple bash script that you can use to automate things. So no, if you want to run them on Hoffman 2, what do you need to do? First thing, and that we already seen before, is the QRSH to request an interactive shell. This way you can just, if you have program, you request an interactive shell, you can just run the program as we did today with the with a / whatever your script is. So that's what we did today. We requested an interactive shell, and then we can run some program this way. And I already kind of explained what that means, and it's also shifted. So I don't know why it shifted. This part here means for how long you want it. By default, it's 2 hours. And this part here is how much memory you need. And so when you log in, you should see, when you're on an interactive node, you should see an N something here. And if you finish before your 2 or 3 hours, what you can do is just press exit, and then it's going to close your interactive node session. And same if you want to close your normal logging node session, you can also type exit, and it's going to close the connection. Okay, so how you can run jobs on Hoffman 2. So you can either request an interactive node and then just run your program, but you can also submit your program to the job queue. So what you can do is this command is queue sub, so that means queue submission. So you're going to submit a job to the queue. And similarly, you can ask for a specific time. So if you have a script that should run in an hour, then you can say, okay, I just need something for 2 hours just to be safe. You take a bit longer. Then I should only need 2 GB of RAM. And then here, so -o is basically whatever your program sprint, then I want to save that into this file. You can, I mean, you don't have to, but you can give your job a name, a specific name. So if you want to recognize them later. Okay. for the interactive session, it should work. I mean, make sure you don't have a space after the comma, after the comments, the -L. So between your HRT and your HData, when you have the comma to separate them, make sure you don't put space. But normally it should work. Otherwise, I would ask the IDRE people why don't get an interactive things, but it's probably a typo, I would say, maybe with the space after the comma. And that's probably that because it's probably going to try to just run a command and exit. So make sure you don't put a space after the comma when in your list of Ingerman. And if you, okay, so for that, so if you don't need to write your input argument or like that. So if you prefer, you can also specify multiple L. So you could write it this way if you prefer. So you could say -L, your first option value, and -L, your second, if you forget. I mean, I also sometimes type a space after the comma, and I know it's annoying. So if you prefer, you can write it this way. Okay, so you can also submit jobs. So similarly, if you submit job, then you need to specify the time you want your job to be allowed to run, what memory you need. This is to say whatever my script should print to the output, I want it to be saved in that file. You can give it a name. You don't have to, but you can. You can also specify if you want to receive an email once your job is done, or if there is an error, or after your job is done. So either when it starts, when there is an error, or when it's done. So if you have long job, that can be convenient to get an email when it's finished. And then if you want to, so this tells that you need to run it in the current directory that you are when you submit. Otherwise, every time you submit a job, it will run on your home directory. So if you position yourself in the directory where you want it to run, then you can add this -cwd, which is current working directory. And then it's going to keep the current working directory and run your script in that directory. And then you just need to specify your program. If your PI don't have done by node, then by default, you can only request up to 24 hours. And if your job use more time or more data compared to what you requested, then it might be just killed without noticed. So that's how you submit to the queue. So we're going to try that. So I made here a very small script that just basically wait for 100 seconds. I think that's what I put. And so we can submit this, and please do. This way you're going to get more used to submitting things. So here it's a very small script and just wait for 100 seconds. So I say I'm requesting only 5 minutes of time and only 1 gigabyte. I don't need all that. And I run, and it's print. When it's done, it's print something. It's print done, I think. We can actually, let me look what I wrote in this script. Yeah, so I sleep for 100 seconds, and whenever these 100 seconds are done, it's just going to print to the screen, done. So we can submit it. So if we submit it, so then you put your options. So here I just want 5 minutes. And then comma, no space. And then I want, because I'm printing something, I want to say where I wanted to save my output. So I'm going to save it in sleep.out. Then I'm going to call it. So I'm giving it a name. It's sleep. And then I wanted to do it in this current directory. And then you just write the name of your script. And so it's going to run that script in your current directory. So then you can press enter. And it's going to submit. It's going to tell you, oh, I forgot the equal. So my bad, typo. That's happened. So my time is equal and not column. Okay, and now it says your job sleep has been submitted. And so when you want to know what's the status of your job, so you have a queue stat. So like queue, the status of your queue. And by default, it's going to print every user, every of my 2 users. So you don't want to see all thousands of scripts that everyone is running. So you can specify your username. And this way, you're going to only see yours jobs. So you can do that. Queue stat, not status, because I was talking and I was saying it means status. Queue stat, and I'm gonna stretch. Okay. So here we can see 2 things. So this one is interactive node. So that's because I'm running on an interactive node. So it's also tell me I have an interactive node here, and that's our sleep program. And right now it's written R. That means it's running. So the couple of things that can be written here is like QW. So that's when you launch it, and it's in the queue, but it hasn't started running yet. Then it's going to be written QW for queued waiting. And when it's running, it's print R. So that should run for 100 seconds. You can also check what's your job are using my job command, and that's basically the same. So it's easier. You don't have to write your username, but that's the same. So it's still running. So it should run for 100 seconds. So we'll wait a bit. And when did it start? 18. It should be almost done. So yeah, so what you have here is the status. You also have at what time it did start and on what node. So basically here, you can see at what time you started your job or my session. Okay, let's see if it's done. Okay, so no, it's gone. That means it finished. So if I list my file, I should have the sleep out. So that this one, that's where I asked it to save the output. And if I see what's in it, oops, sleep out, then you see knowing that I have it done, that I have my script to print. And you can notice it also created this here. So that's basically where any error, if any error would have print, that's in that file that it would have printed. So if we check it, we shouldn't have any error. And so it's empty. But if anything's wrong happened and something was sent to the standard error output, then it would be in that text file. So that's sleep, that's your job name. And then the E means error, so that's how you recognize, and that was my job ID. I know you can set up your email. I would tend to think when you register, you put your email, so you don't need to specify it. So I don't think you need to put your email afterwards. You just put when you want to receive email. So this here says, I want an email before when I get an error or after my job is done. But I think it will use the email you use when you register to the Hoffman 2. I don't think you need to tell him what email. Okay, so a couple of things. So if you realize that you made a mistake in your job and you just want to kill it, then you can use this qdel. So that's mean q delete. And that's going to kill your job. So we can try that. We're going to resubmit my job. That's the one that don't have a, I'm going to call it sleep 2, for example. Okay, and now if I do my jobs, then I see, oh, okay, so I see it's like queued wait. So it's not running yet. I mean, you can kill something if it's running or not running, so you can stop it. And so you would need to specify your job ID, which is this thing here. So you can say q delete, and I'm going to delete this job. And so it says it has been registered for deletion. And so if I redo my job, either it's gone. Yeah, so it's already gone. So you see, it didn't finish because I removed it from the queue and killed it before it's done. So if you realize that you made a mistake in your script and you don't want for it to finish, or if it's not even started, you can just remove it, correct your mistake, and just relaunch it. Off-Man2 has some quotas instead of how much space you can use and how much file you can have on your home directory. And so if you want to check that, you can type my quota, and it's going to list how many files you have in your file system, how much you can have. So like in my Scratch, I haven't run anything recently. So I don't have anything in my Scratch file. I just have folders because I don't delete folders. So that's the number of files. That's also the space you're allowed on the Scratch. So you have 2 terabytes. Scratch folder is temporary. So I think after a week, they're going to remove it. So you can, it's convenient because you have more space. So when you need to run a big analysis, you can put that in the Scratch storage. But when you're done, you should copy that to your computer. So you have 2 terabytes of space in your Scratch storage. So you can see here. And as I said, I haven't run much lately, so I don't have anything in my Scratch. And you also have how much usage you have for your file system. So you have only 20 gigabytes. And so you can see how far you have, and you only have 200,000 files. And so I have a bunch because I run a lot of stuff. So that can allow you to see if you're running out of files, numbers, or space. Okay, and so couple last thing on Off-Man2. So a lot of programs are already installed on Off-Man2, but you can't access them by default. You need to load them first. So how it's work, they call basically module. And so if you do module avail for available, it's going to list all the different software that you can load. So all the different software that are installed. So we can see, for example, if you're doing, you have some VCF tool for variant analysis. You have Subhat for some NGS, RNA-seq, or you even have Stata, like Stat program, SAM tools. You have different versions of SAM tools that are installed. If you're doing NGS analysis, for example, you have Python. So you have a bunch of software that are already installed that you don't need to install yourself. You just need to load them. So you have MATLAB, you have Mathematica, Julia. So all these, so if you want to see what's available on Off-Man2, then it's a module avail for available. And you can also list what you have loaded so far in your session. So here we haven't loaded anything, but basically just Intel, just a processor. So you have like 2 modules that are loaded by default. You can, and if you want to run Python, the first thing you need to do is to load the module Python, or if you want to load SAM tools, then what you would do is you would say module load, and then, for example, SAM tools. And then now, if I do module list, I have SAM tools, and when you load SAM tools, it also loads a couple of other things. So you can see now I can access SAM tools 1.9. And so then if I type the command, then I can choose SAM tools and run whatever I want. So if you, for example, if you run that in a bash script, if you do a shell script, then that's something you'll need to put at the beginning of your shell script. I mean, after the shebang, you're gonna load all the module you need, such that when you start your script, Hoffman2 will load the right module, and then you can use SAMtool, for example, downstream in your script. And so if you're doing it interactively, when you're done or at the end of the script, you can just unload whatever. I mean, I don't think it's a big deal if you don't unload them, but you can unload them. So you would unload SAMtools, and now if I try to type SAMtools and I autocomplete, there is nothing. So that means it's not loaded and it's not available to me. So that's type of command you'll need on Hoffman2 to kind of see what's the submit job, what's the status of your job, delete them if you made a mistake, load specific software that are already installed on Hoffman2. Yeah, so you can see if that's what I was saying. If I don't load it and I do SAMtools, then you can tell me it doesn't exist. And when I load it, then I can use it. Yeah, so that's summary for today. So we saw awk. That's a very powerful text processing software. We saw how to do some shell scripting. We saw how to submit job on Hoffman2, either ask for an interactive job or to submit a script. We saw QStat and my job to know the status of your job on Hoffman2, if they're running, if they're still waiting, and so on. You know how to delete a job if you notice that you made a mistake or that you have a while loop in your script or a for loop and you make a mistake, it's going to wait forever. It's going to loop forever. You can delete it. We've seen how you can check what's your Hoffman2 usage in terms of space, number of files, and so on. And how to list the different software that are available on Hoffman2 and load them, unload them, etc. Okay. So as a summary, I mean, feel free to check online, try to find some cheat sheet. That's always useful. And I never know how to find a cheat sheet. I probably somehow fall. But yeah, so that's super useful. You can definitely Google them for a bash cheat sheet that's just going to have a summary of the super useful command, how to use them, what they mean, etc. Same for awk. If you like awk to process something, then having a cheat sheet is super useful. And there will be plenty online, so you can definitely take some and do that. Okay, so I have a couple of practice. We can do it. Oh, yeah, I did make a break. So we can just, if you want to, I mean, we can do it, or if you want to do it on your own, you can also try. So I have the answer here. Some more awk command. I mean, we basically did the same thing. I actually forgot to put the +1 in this length. So that's my bad. Okay, so now I made you a quiz. So it's here. I'm gonna put the link on the chat. So if you're taking the class for a course like 275 and so on, you have to take the quiz. Otherwise, you don't have to, but I mean, it's always good to check what you learn on the quiz. And so you still have time, like half an hour, if you want to do the quiz right now. On the quiz, I'm asking you your email. This way I can know who's taking it. And so it's probably easier if you write the same email as the one you register to the workshop. That's going to be simpler. And I'm gonna, I think you also need, so if you're taking the workshop for any class, you need to take the quiz. And even if you don't take for any class, I would definitely recommend you to take the quiz. It's like to check what you learn. So anyone that's taking the workshop for class, take the quiz, you have to. So that's this quiz. I'm going to put the link in the chat so that you can just open it easily. I'm gonna grade on Monday, so I'm gonna leave it open up to Sunday, so you can like go back, or if you made a mistake or so on. Yeah, so that's it. I think that's it. You can do it right now. I mean, that's why we finish a bit in advance, to leave you time to do it. I didn't set just one attempt. I said that you can edit after. So when you submit the first time, you should be able to have a link to edit. So you should be able to edit until Sunday. Yeah, I'm gonna grade on Monday, so I'm probably gonna stop allowing submission either on Sunday night or Monday morning. So I would do it before Sunday night, at least. So I'm gonna copy that, like copy the link in the chat so that you can open it easily. And so you can take it right now and I can answer a question if there is any. I'm gonna stop the recording.